Distinguish between proportional and non-proportional situations using a table. If there is a constant rate of change in the data displayed in a table, then the table represents a non-linear proportional relationship. A linear relationship represented by a table is a proportional relationship where the quotient of each pair of numbers is constant. Otherwise, the linear relationship is non-proportional. All right, and this video should help us get through example 3.
All right, now let's take a look at some data and determine if the data is connected through a direct variation. So here's a bunch of stuff, and I want to see if this relationship is really a direct variation. So here are the x's and here are the y's. Well, there's two different ways of doing this, and I want to show you both ways. One way is just to see if we can write down an equation that links the x and the y together. So let's see if we can look at the equation. Let's just look at the data here and see, okay, so does y equal something times x that works for all these things? Well, notice that y6 equals, something times x, it equals 3 times x. Does that hold here? Does 9 equal 3 times 3? Does 15 equal 3 times 5? So in fact, I see that y equals 3x. And yes, that's of the form, so yes, we do have a direct variation. And in fact, the k is equal to 3. So that's one way of doing it, actually writing out the equation, and then seeing that it has the right form. There's a different way, which is to say, you know what? I want to find the ratios y over x. And if those are always constant, that should give me the k. Because check it out. If I take the direct variation formula and divide both sides by x, then I have y over x equals k. And so that should be constant. So let's see what happens. So if I take y over x, I see 3. By the way, we already know the answer, and that's looking good, but pretend we don't know that. Let's look at the next one. Y over x, and that still equals 3. Great. And then the last one, y over x equals 3. So since I see 3, 3, 3, I see this is a constant. So I see, in fact, that we have a direct variation, and I see that the y over x always equals 3, which if I multiply both sides by x, I see y equals 3x. And I'm back where I was before, and the k again is 3. Neat. So we can see that this, in fact, this relationship is direct variation. How about another example? So here's a relationship, and I want to see if it's a direct variation or not. So let's just first look at it. When x equals 1, when x equals 0, y equals 1. When x equals 2, y equals 3. When x equals 6, y equals 7. Can you see a pattern? Let's first see if we can write down a formula for this. I see it. When I plug in 0, I get 1. When I plug in 2, I get 3. When I plug in 6, I get 7. Notice the y is always 1 more than the associated x. And so I see y equals x plus 1. Well, is that something that's a direct variation? No, because that plus 1. So no, it's not a direct variation. That's one way of seeing it. The other way is to actually, look at the y over x ratios. So the first one is going to be 1 over 0. That's undefined. Not a good start. The next one is 3 over 2, which equals 3 over 2. That is defined. And the last one is 7 over 6. Well, now wait, 7 over 6, could that possibly be equal to 3 over 2? Well, we can see. We can actually multiply top and bottom here by 3 to get a common denominator, and I see this is 9 over 6. 9 over 6 is not equal to 7 over 6. This is not a direct variation. We can see that right here. So either way shows us not a direct variation.
Comparing proportional and non-proportional situations. You can use what you've learned about proportional and non-proportional relationships to compare similar real-world situations that are given using different representations. All right, in the upcoming video should help us understand example 4.
There's lots of different types of relationships. Some are proportional and some are not proportional. Let's take a look at a couple of real-world examples where we can try to analyze what we have. Okay, so the first thing I want us to think about is that student council has a choice between 2 DJs for their spring dance. In both cases, X is the number of hours and Y is the total charge by the DJ. Let's compare and contrast the 2 situations. Okay, so for DJ A, here's the story. DJ A says, you know what? Here's all you need to know. Here's the equation. Y equals 40X. Now remember, X represents the number of hours, and Y is the amount charged. So for 1 hour, it's $40. For 2 hours, it's actually going to be $80, and so forth. This is an example, of course, of a line. And we know that if we think of it this way, we have that B represents the y-intercept, and M represents the slope. Well, since the y-intercept is 0, what that means is this is really a proportional relationship. It means that the B is 0, which means that this is actually going to start at 0, 0. That means that if he doesn't work or she doesn't work at all, the cost is 0. That means there's no initial fee. There's no initial fee at all. However, what's the per hour rate? Well, we know where to find the rate. That's slope, so it's $40 an hour. So, DJA, what do we got? We see no initial fee, and it's $40 an hour. Boom. There we go. Now, what about DJB? Well, DJB is going to give us the information in a slightly different way, because DJB says, hey, I'll just show you a graph that shows you the total cost. And so here's the total cost. Check it out. Hours for X and Y is the total cost. And so what do I see? Well, I see a straight line, but notice it doesn't pass through the origin. So this is not a proportional relationship, but it is a linear relationship. So I can actually find the equation of the line. It still is going to conform with this. And the first thing I notice is what the B is. What's the B? Well, that's the y-intercept, which is right between 40 and 60, so that's 50. And so I see the B is 50. So I see for this situation, B equals 50. And what about M? M is the slope. So to find the slope, I need to have 2 points and look at the change in Y or the change in X or Y's over 1. 1 point is easy. Let's just use the point 0, 50. That's the y-intercept. And how about this point right here? Do you see that point right there? That point is at 2. And over here, 80. So what's the slope? Well, the slope is the change in Y, which is 80 minus 50, divided by the change in X, which is 2 minus 0. And 80 minus 50 is 30. 2 minus 0 is about 2. And so 30 divided by 2 is 15. So I see that this line has slope 15. Slope 15. And so, in fact, I can get rid of all of this stuff that we just figured out, because we don't need that anymore. We have the slope. In fact, I don't even care about these points anymore. Do you? I don't think you do either. So we have the slope, and so therefore, if we now plug into the standard formula for a line, what we see is y equals 15x plus 50. And so what does that mean? Well, it means that what we see is the initial value, if there's 0 time spent, it's $50. That means that for this DJ, you have to pay $50 in advance, just like kind of like for making an appointment, you pay $50 up front. And then what's the rate per hour? Well, that's the slope, which is $15 an hour. So how do we compare these 2 DJs? This DJ has no initial rate to pay, no initial fee, and it's $40 an hour. Here, you pay an initial fee of $50, but then only $15 an hour. So both same interesting depending upon how long you want them to play for. So there we analyze both situations. Here we have a proportional relationship. Here we have just a linear relationship. Isn't that great? I think it's kind of fun. So now we've analyzed it. Let's take a look at another question, and I'm going to sweep this clean, and let's try again. Now, Rolanda wants to hire a personal trainer. She has a choice between two different trainers. In both cases, X is going to represent the number of hours, and Y will represent the total amount charged for that training. Let's compare and contrast these situations. Okay, so here's what we're given. For trainer A, we're told that the equation, this is for A. Ooh, in fact, let me just, okay, I forgot to write A. Okay, everyone calm down. I can see you're getting very upset with me, but I can fix this in a second. Watch me. You watching this? I'm just going to take that. See? Thought I couldn't do it. And this is A. So trainer A, all we're given is this. Now remember, X represents the number of hours, and Y is the cost. So this we see is, in fact, a proportional relationship. It's of the form Y equals mx plus b, where b is 0. And so what I see here is that there's no initial fee. Because remember, the equation for a line is Y equals mx plus b, where b is the value when x equals 0. Well, when x equals 0, there's no fee. So there's no initial fee, but this represents the constant rate, or the slope, which we see is 30. That means it's $30 an hour. So this is saying no initial fee. No initial fee. That's good. And then it's $35 per hour. Let's just check that out. If x is 1, that means 1 hour. This works out to be 35. If x were to be 2, then 35 times 2 is 70, and it's $70, and so forth. It's $35 an hour. That's the rate. Okay, done. Done and doner. Now, what about for trainer B? Well, trainer B actually gives the information to us in an unusual way. Trainer B gives us a little table like this, and we have to kind of figure it out for ourselves. So first of all, is this a proportional relationship? We just would have to look at the ratios here. You can't divide by 0, so we have to look at these ratios over here, and let's see what we get. Well, I did that for us, and check out the ratios. Tell me what you think. 45 over 1 is 45, but 75 over 2 is 37.5. The next ratio is 35. The next ratio is 33.75. These are not constant ratios. This is definitely not a proportional relationship. So get that away. All right. So what do? Well, I do notice that when x equals 0, if Rolanda doesn't meet with the trainer at all, it still costs $15. That means this must be the initial fee. So the initial fee here is $15, or that's the y-intercept. So y-intercept, or the b, if we look at y equals mx plus b, we see that the y-intercept here is going to be 15. And now, what about the change, right? What's the slope? Well, how do I go from 15 to 45? What do I have to add here? I have to add 30. And what do I have to add to 0 to make it 1? I have to add 1. Okay, now let's see what happens when I go from 45 to 75. What do I have to add to 45 to make it 75? Well, it's 30. What do I have to add to 1 to make it 2? It's 1. And now you're seeing the rate, 30 over 1. 30 over 1, it seems to always be the same. Let's just confirm that. How do I get from 75 to 105? I add 30. How do I get from 105 to 135? I add 30. How do I get from 2 to 3? How do I get from 3 to 4? I add 1, I add 1. So I see what the slope is. It's the change in y over the change in x. The slope we see is 30. So the equation for this line, it's not a proportional relation, but it's a linear relation, is y equals 30x plus 15. And how do we actually translate that into words? Here we see an initial fee of $15. So initial fee, you pay $15 up front just for walking in the door, even if you never get exercise. But the great news is, what's the hourly rate? What's the rate of change? What's the slope? It's $30 an hour. So again, we see it's a little bit less, but you pay a $15 one-time fee. So again, depending upon how often Rolanda is actually going to use the trainer, it will make sense either to go with A or with B. 2